Hey, hi everyone. Can you see me? Uh, just like always, if you can see me, just please comment yes so that I know. And yeah, also tell that if I'm audible. Let's wait for a couple of minutes. Just a minute. Okay, I think someone commented yes, so I think I'm visible and also audible. Okay, guys. So let's wait for 1-2 minutes and let other also join, and then we can start. Cool. Thanks, Venkatesh. Okay, I hope everyone is doing fine. And yeah, so let me just give you brief intro for today's session. So today we are going to learn Git. And again, if you are a complete beginner, even you are in college or maybe you have started working but don't know about Git, so it's going to be a very basic session from scratch as always, and we are going to start from beginning. So the only expectation is just don't start working side by side. I mean, don't start repeating a side by side. You will get ample amount of time after the session, and we also prepared an assignment, basics assignment, so that you can do the practice later on. This today's session will not be that big one. That's why we have divided the session into two parts, part one and part two. So part two will be most probably tomorrow. I'll update on LinkedIn, so you can subscribe the channel so that you will directly know. And yeah, so I think it's already 6:01, and I think it's time to start. And yeah, so one thing is like today's session will be taken by Prashant. Let me bring him to the stream also. Hey Prashant, you have joined me. So just a minute. So Prashant will be taking today's session, and he has he has also taught Git in his previous organizations. Currently, he's working in Google. So yeah, I'll be also in the stream. So if you have any doubts, I'm going to answer in the chat box. Again, be patient, and if you're not understanding anything, please feel free to add your comments in chat as always. And yeah, and then I think we can start without wasting much time. So okay, so let me
Thanks
share
a
this.
lot, Shikhar.
Okay, yeah, Prashant. Hi.
Okay, yeah, thanks, Shikhar. So, hey, everyone, we'll get started now. So, this is a session on Git, and basically now we'll try to cover some basic commands of Git. And in the next session, we'll try to deep dive more into the advanced section of Git. So, this session is mostly for the beginners, and hopefully it will help you out. Okay, so let's move forward. So, first thing is, why are we studying this, and what is this actually? So Git is a version control system. Now, to talk about what is a version control system or what is a VCS, I think all of us have used one or the other form of VCS at some point of in our life, right? For example, let's talk about the college, right? When we were preparing a presentation. So let's say we prepared a presentation, some version of presentation, and 2 days later we decided that, hey, what we want to do is we want to change this presentation and add some more data to it. But we also want to keep our older presentation in end, just so that in case we mess something up, we can go back to previous presentation, right? So we create a copy of that, and then we start editing the new copy. So that is what version control system is in very basic terms. Obviously, there are a lot of things which we add on top of this, but version control system is something that we use so that we can keep a history on multiple versions of the file that we added. Right. So yeah, now let's talk about different kind of version control systems that we have. So there are basically three types of version control system. First one is called local, second one is called central, and the third one is called distributed. So yeah, so this image should help you understand what is like these three type of version control system. So just me, yeah. So first kind of version control system is called as the local VCS. So what happens in this case is all the versions of your file reside in your local computer, right? Now, like this was a version control system that was used some time before, but there are certain problems with that, right? For example, what if your hard disk get corrupted, or what if you want to share this code with some of your friends? Then it becomes very difficult to do this with the local VCS. So after this, another thing came into picture, which was central VCS. In this, what happens is all of your versions data, which is the complete history of your version control system, resides in a shared repository, which is like you can assume some sort of cloud system. And then everyone who is coding into that system, they get the version information from that system. Now, it actually solves a little bit problem over there, but now it's still like there are certain problems here. For example, what if you do not have internet as of now, and you want to look up how your code looked like at some point of time in history, right? The other problem is, what if this shared repository goes down? What happens to your code in that case? So to solve all of this problem, we started having something called as distributed version system. So what happens in a distributed VCS is your remote system, as well as every local system, the system of every developer who is working on this, they have the complete history of their VCS. Okay, so this is what Git does. So everyone who is using this version control system Git, they have the complete version history with them. So this solves all the problem with local VCS or centralized VCS. So yeah, so now like, why do we use Git, right? Or any version control system for that matter? First thing is, what if you do something wrong? What if you make some mistake? So VCS allows you to correct those mistakes. And what if, let us say you're working on a project and 5 days later you realize, hey, the solution that I was implementing 5 days before, that was the correct solution. So version control system allow you to go back in that direction. The other thing is backup, right? You don't want to lose all your 5 or 6 years of code. So if you all of your systems in VCS, you can't really lose that. So yeah, now now moving on to Git, what are the benefits of Git? First benefit, which I like a lot, is called as how Git actually stores your files. So Git stores snapshots and not differences. So this is like one of the biggest difference between Git and other version control systems. So what other VCS were doing was, you have a file, let us say it has one line, right? And then you add one another line to it. So other VCS, what they were doing is they were trying to find what is the difference between the earlier version and the new version, and they were only storing this difference. So it was also known as delta-based versioning. But Git did like something different. What they started doing was they started storing the complete snapshot of file whenever you make any change into that file. So this like seems a bit counterintuitive, that why do you want to waste so much space, right? But the benefit of this is tremendous. Let us say you've been working on a file for over a year. You have been creating like a lot of versions of it, and you immediately want to see what is the difference between this file as it looks 1 year back and as it looks now. Git can calculate that difference really fast because it knows exactly how the file looked 1 year back and exactly how it looked now, right? But for other VCS, they had to like keep on applying multiple datas from 1 year back, and then only they can find the difference. So like this is one of the very good thing about Git. Git does some optimization on top of it. For example, if you don't change a file, it won't really store that file again. It will just keep a reference that, hey, this file was not changed. So I'll just pick it from some other point in past. So yeah, that's one thing. The other thing is, which is really useful, is every operation that you do in like Git is very local. So unless you actually want to share your code with someone, you can actually code whatever you want in Git without ever having to connect to internet. So you only need to go online when you actually want to share your code with someone. So this is actually a really nice one. The other thing is, it is very difficult to mess something up in Git. So what Git does is, whenever you make any change, Git calculates, Git basically looks at that change, looks at who made that change, at what time that change was made. So it takes all of this information and calculate its hash. For those of you who don't know what hash is, hashing is basically a technique in which we calculate some sort of checksum for a file. So for example, Git calculates this using something called a SHA-1 hash. So that's why if you like make any mistake, Git will always know it, because Git knows how the file looked because of its because hash would change as soon as you change it. The final thing is, Git never deletes any of your data. So whatever change you make, if you add a line to a file, if you create a new file, if you rename a file, or even if you delete a file, the Git always stores all of this as an addition. Even your deletion would be stored as addition saying that this file was deleted. But your file is never actually deleted. So it is always possible to go back in time and see how your data look like. So yeah, I think these are all the benefits of Git. Now, um, what we'll try to see is how Git manages the data. Okay. So this is also known as Git's directory structure, or the three states of Git. Okay. So let's look at this top image here. In Git, you can divide your the project that you're working on in three different areas. The first one is called working directory. The working directory is what you see when you open your project in a Git repository. Okay, so whichever files you're seeing is called as your working directory. So in other terms, working directory is a snapshot of your code at any particular point of time. Okay, so now what you'll do in your working directory, you'll make some changes. Maybe you'll add a function, right? And once you do that, you need to tell your Git that, hey, my changes are ready and they look good, and they are ready to go into the next snapshot that I'll create, or the next version that I'll create. So once you do that, the code changes actually move to staging area. The staging area is basically saying my code changes are now ready to be moved into the next version that we'll create. After this, what we do is we do a commit, or you can say we take a snapshot, or we basically want to store our all the changes that are ready. So once we do this operation, right, once we do this commit operation, all the changes that we had, they move to Git's database, something that is also known as .git repository or .git directory. Okay. Now, yeah. So now this is how like we divide Git into different sections. Now let's try to look at from the file perspective. If there is a file, how its life moves as we make some changes to it. So initially, when you create a file, the file is called as an untracked file. Okay, Git doesn't really know about it. Now, what we do is we ask Git that, hey, can you please start tracking this file? So that is known as adding the file. And once you do that, the file goes to this staged area. That basically it means that it is now ready to be moved into Git .git directory as soon as you commit this change. Now, if you're okay that, hey, this code looks good, you say to Git that, hey, can you please take a snapshot? Can you please commit this file? And then what Git will do is Git will take this code and move it to its database. And now you move to a stage where you no longer have any modified files with respect to Git, right? Git has stored everything into your into its database, and there are no more changes which you might lose. So all the changes are now stored. Now, what you can do with that file again, you can maybe add one more function to that file. So that is called as editing the file. As soon as you edit a file, it becomes a modified file. Now, this file might not be ready, right? We might have written some function, but that function might not be ready. It might not be complete. So once we complete that function, and we know that the file is now ready to be saved into Git, we say to Git that, hey, can you please stage this file? Or basically saying that, hey, Git, this file is now ready. As soon as we do that, the file moves to the staged area or the staging area. And after that, what happens is we basically say to Git that, hey, can you please commit this change? And again, the same cycle repeats. Same thing also happens when we remove the file. Once we remove the file, the similar thing happens. We still need to add it and move it to the ready area, and then again do a commit. So yeah, I understand that this might look complex, but don't worry about it. We'll take a lot of examples, and once we go into examples, it should be like very easy for you to understand what is happening over here. So, yep. So now what we'll do is we'll look at some of the commands in Git, right? But before that, I just want to clarify something. Whenever someone looks at a Git tutorial, the first thing that comes to mind is GitHub or GitLab, right? that how do we create project over there. But we are not covering that in this session. That is something that we'll cover in our next session. Because first thing that we wanted to show you is how to do all of this locally, right? When you are working on a project locally, how do you do all of this? So that we first understand the basics of Git, and then only we go into sharing our code with someone, which is where our remote come into picture, either GitHub, GitLab, or the other systems out there. So yeah, I think now what we'll do is we'll see how all of this works. So yeah. So now first what I'll do is I'll create my project, right? So creating a project as some directory where we'll be working on. So let's create something as Git tutorial. So let us say this is my project data directory where I want to create some project. Okay.
Yeah, sorry to interrupt.
Now,
Is the
yeah.
font fine, or do we need to increase? Prashant, can we increase the font a little bit?
Yeah. Does that look okay?
Yeah, I think it's better now.
Okay, great. So yeah, now we have a folder which is ready to be turned into a Git repository. Okay. Now there are like certain commands present on this page, right? Git init, status, add, commit, and so on and so forth. We'll learn these commands in almost this order only, and yeah, let's see how that goes. So first command should be turning our project into a Git project. Okay. So first, how do I know that this project is not a Git project? For that, the command is called Git Status. So Git Status is a command that you'll be using like very, very frequently. It tells you the status of a Git project. Okay. So let's check what it is saying. So as of now, it is saying that, hey, this is not a Git repository. So this is something that we need to still convert this into a Git repository. So the command to convert a normal directory into a Git repository is called as git init. So as soon as you write this command, it will convert your project into a Git repository. Okay. So let's see what happens after this when I ask Git to give me some status. So Git is like now no longer giving this error, right? That it is not a Git repository. It is telling me some things. So the first thing it is telling me that you're on a main branch. So this is something, let's skip this for now. I'll be covering branching in a short while. Okay. For now, let's look at what other things that we have. Git status is also telling me that there are no commits yet. Okay. Whenever we use term commit, you can also think of it as a version or a snapshot, that how your code looked like at some point of time in history. So Git is telling me that, hey, you don't have any history here. You can't look at any code. And the Git is also telling me that, hey, you don't have any files that you can commit as of now. So let's give Git a file to work on. Okay. So let's create a file hello.txt and let's put some content here. So, okay. So we have created a file called hello.txt. Okay. And this file contains nothing but hello world. Okay. So now let's see what Git has to tell us about this file. So we do git status. Now git status is telling me that, hey, you don't have any commits, but you have a file called hello.txt, which is a untracked file. Okay. And like git status is a command which is like very verbose. It tells you how your Git directory looks like, what all files are there, what is the status of those files, and also it tells you what you can do to move forward or fix your issues. Okay, so it is telling me that hello.txt is an untracked file. So if we go back here, untracked file is where everything starts, right? And we need to now add this file to make it ready or move it to the staging area. So how to do that? So the command to add a file to staging area is called as Git Add, right? So when we run Git status, Git told us that, hey, this is an untracked file and you should do Git Add file name to include in what will be committed. So it means if you do Git Add file, this file would be included in the staging area and would be committed the next time you take your snapshot. So let's do that. Let's add this file. Okay, so it's added now. Let's again check Git status. So now what Git status is telling me that, hey, you have a new file called hello.txt and it is present in staging area. How do I know that? Because it is telling me that as soon as you commit this change, this file would be committed. And along with that, it is also telling me some other information. For example, it is telling me that, hey, if you want to move this file out of the staging area, you can use this command, which is git rm-authenticator. So you'll see a lot of such hints given by Git status from time to time. So for now, what we'll do is we'll go ahead and save this file, okay? So to do that, the command is called git commit. So what does git commit do? Git commit takes everything which is present in your staging area and saves that into Git's database. Okay, so let's run this command git commit, and it opens a UI for us, and it is asking that, hey, can you please enter a commit message for your changes? And then, yeah, some other information that, hey, these are the files that you're committing, and some other information on top of that. So let's add some comment. Edit file hello.txt. By the way, this is something that I think like is very important, that the commit message that we enter are like meaningful, because generally when you run into some issue, you look at your Git history or you want to go back to some particular point in time, you would like to have really nice commit messages. So you understand just by looking at the commit message that what happened in this place. Okay. So in this case, we'll give this commit message, which is added file hello.txt. So let's save this file. And now see, after doing git commit, it is telling me something that, hey, there was one file which was changed. It had one insertion that we know because it was just one line. And it is also telling me something important, that it is a root commit. So a root commit is the first commit that happens in a Git repository. Okay. So now it's time to learn the next command. This command is called as Git Log. So what does Git Log do? Git Log tells you the history of everything happening in your project. Okay. Sorry, one thing that I missed was this particular number here, which is db9e970. So what is this? Git took the file that you created, all the content of it, along with some other information here, like who created this file and what was the time at which it was created, and used all of that to create a SHA-1 hash. So this is the first 7 characters of that SHA-1 hash. And this is also sometimes known as your commit ID or your commit number. Okay. So now, yeah, let's go back to Git Log and see what Git Log is telling me. So Git Log is telling me that, hey, you only have one commit. So remember, commit is a version or a snapshot, which has this SHA-1 hash. So you remember those 7 characters that we saw are same as this. So that was just a short form of this. And then some other information that, hey, author for this was Prashant Gupta, there was this email ID for them, and then the time at which it was created, along with commit message. Okay. So now, what if you want more information out of this? Okay. So there is one more command, which is like sometimes useful to check what happened at a particular version. For this, let me copy this commit ID. That command is called as Git Show. So what Git Show does is it takes a commit ID and gives you all the information about that commit. So yeah, so Git Show is basically, sorry. Yeah, so Git Show is basically telling me that, hey, this was the commit, author, date, what is this commit message, and along with that, what happened in this commit. So what happened in this commit was a line was added called hello world in a file called hello.txt. Okay, so this is about Git Show. Now, what we'll do is we'll try to make some changes into this file. Okay. So how do we make those changes? So let me open this file. And instead of hello world, we'll say hello universe. Okay, so now we've changed this file. It is same as like when you are making some code changes. Okay? Now let's see what Git has to tell about this file. So now Git is telling me something. Git is telling me that, hey, you have a modified file called hello.txt, but it is still not staged for commit. It means it is still not ready. And if I want to commit this, I still have to make this ready. And it is also telling me how to do that. It is telling me if you want to make this file ready, do a git add file name. And if you think that this file is like not okay and there is some issue, you can just discard the changes in this file by doing a git restore file name. So what git restore file name does is it discards all the unsaved changes into this file. So if I do a git restore hello.txt as of now, I would no longer be able to see hello universe. Instead, I'll see hello world. Okay, but before doing this, okay, I think yeah, we can do that. That is okay. So let's do git restore hello.txt. Okay, but before that, let me show you what is present in hello.txt. It is currently hello universe. Okay, and if I do git restore hello.txt and now try to see what is present in this file, it is just hello world, right? So now those changes which I made, which were not ready, are now gone. So let's get those changes back. So now, again, we have the same set of changes. Now, this is a time to learn one more command. This command is called Git Diff. Okay. So what does Git Diff does? Git Diff is a useful command to find out what are the differences between the changes that you have now in your working directory as compared to the last changes that get saved. Okay. So in other words, whatever modified changes that you have, Git will compare these to the last commit Git stored and tell you the differences over there. So let's run Git Diff here and see what it is telling me. So Git Diff is telling me that, hey, you have one deletion and one addition in this file called hello.txt. And what is that? You deleted hello world, and instead of that, you added hello universe. Okay, so now we know what our differences is. We'll try to like save these changes, and the step to save these is same. First, I want to move these to staging area, which is done by Git Add, and now I have my changes in staging area, right? Because I do Git Status, it tells me that, hey, now your changes are ready to be committed. So now, again, let's check what happens when I do Git Diff. Remember, Git Diff only takes your unstaged changes, which are not ready, and compare those with the last commit. So as of now, if I try to do a Git Diff, I will not see anything at all. Why this is happening is because this change is no longer just a modified change. So yeah, this is currently present in my staging area. So Git Diff doesn't look at that. Okay, so now let's go ahead and ask Git to commit this change, okay? Now earlier what we did was we ran command git commit and it asked me to put a message. It is also possible to put your message in a short form by passing a flag called -m, which is a short for -- message. So whenever I do that, what happens is I can directly pass a message over here. And in that case, let me give a message to global. Okay, so once I do that, it will create another commit for me. The commit ID for this is 052DBFF, and the commit message is called go global. One file was changed where we had one insertion and one deletion. This is something that you can always look back by again using the command git log. which will tell me the complete history of my Git project. For example, here it is telling me that, hey, this was the commit that I had, which said, which message was go global. Before this, I had one more commit, which said added file hello.txt. Okay. So now, again, the same thing. You can take this commit, or even not all of it, right? Maybe the first 7 characters, and then do a git show commit ID, and it will tell you what happened in this commit, which is we change hello world to hello universe and the other information about this commit. So yeah, just a second. Let me send this. Yes. So yeah, I think we did all of the commands over here, except the last command, which is like very important command, which is called as Git Checkout. So all of this is like not very useful if we can't go back to any past version in our code. Okay, so that is like the most important function of Git, right? You made some changes, but you want to go back into past and see what is happening over here. So that's where Git Checkout comes into picture. Git Checkout is a command which is used to go back to any version in your Git history. Okay. So yeah, let's try to see that in action. First, let me show you how my project currently looks like. My project has a file called hello.txt. And if I do this, try to look at this file, it currently says hello universe. Okay. And if I do git status, it tells me that, hey, there is nothing in my code which is not committed or anything. So we are good to go. Now, what I want to do is I want to go to my previous version, which said hello world instead of hello universe. So how can I do that? Let me do a git log. So this was the commit where I first edited the file and it did not have universe in it. So I take this commit, okay, and then what I do is I do git checkout this commits ID. Okay, you don't have to put the complete commit ID. You can just take the first 7 or 8 characters and it will still work. And once I do that, now this is telling me some more information, which is not like very important as of now. But for now, what you can understand is now you're presented a commit which is different from where you were just now. So if I try to check what I have, I still have a file called hello.txt. Let's check what its content are. So see, this now says, hey, your file now has hello world instead of hello universe. So like this is like one of the very important properties of Git. You can go back to any commit and see what is happening over there. So yep. Now, having said that, now we'll move on to the next concept called as branching. Okay. So this is like one of the most important topic in Git, and this is the reason why like Git is so favorite to everyone. Like you'll find yourself in a situation where you have to like work on multiple tasks at the same time. So that is where like branching helps you out. For example, let's take a scenario. Let us say you're working on a code and you're developing some sort of feature over there. Okay. While you're developing the feature, someone comes back to you and says that, hey, can you fix this important bug? So you cannot like discard all of those changes. So that's where like you'll really find the usefulness of branching. That's why we should use branching. So, but before that, there is like some concept that we need to learn. For example, one of the very simplest concept is what is a branch? So for those of you who know data structures and algorithm, this is very similar to what happens in a tree or a graph. A branch is basically you had one path that you were following, and then you started following some other part. So you had a parent which has 2 childs, something that happens in a tree data structure a lot. So Git branching is also very similar to that. Actually, Git is something called as a directed acyclic graph. So if you're making some changes and then you basically want to leave those changes as it is and start working on some of the changes, you create a branch out of it and start working on that. So what we'll do is we'll take a very simple example and try to understand this better. Okay. So for that, what I'll do is I'll take help of this really good tool, which is a good tool to visualize Git. And let's see how everything happens over here. So remember, by default, Git creates a branch for you. That branch is called as a master branch. Okay. But generally, when you're working, you'll keep on creating your own branches. So let's take an example. Let's say your professor gives you a task that, hey, you are given a file and you want to implement 4 operations in it: addition, subtraction, division, and multiplication. And your professor gives you a time of 7 days to do that. Now, you'll say, yeah, 7 days looks good enough, I can do that. And you say, I'll do like 1 task a day, right? So what you'll do is, at first day, you'll implement addition in your code, okay? And once that code is ready, you'll commit that saying now, okay, my additions code is saved, right? I won't lose it. So what you do is git commit -m addition. So see, now what it did was it created another commit where your master branch is pointing and where your head is also pointing. I think head we didn't cover, but like in very simple terms, head is where you're looking right now. Okay. So what you're seeing in your working directory at a point of time is called as head.
Can we increase?
Yeah.
Can we zoom the screen?
Yeah, sure. Is that better?
Yeah, I think it's fine now.
Okay, great. Yeah, thanks for reminding that. So, yeah, so what was our head? Head is basically how your working directory looks at a point of time. So for example, if your head is here, okay, you'll see the addition changes. But if your head has been here, you won't see those addition changes in your system, right? So for example, what we did using checkout, right? We took the commit ID, we did a git checkout commit ID, and our head moved over there. So now we no longer see our addition code when we look at our working directory. That code is gone. So now, yeah, let's go back get that code, right? So for that, we'll do git checkout master. So master is the name of the branch present over here, which is the default branch present in Git. So yeah, now our head is here. We can see the addition code. We're good to go. It's now day number 2. We implemented subtraction, and we say that, hey, let's save this code so that we don't lose it. So, yep. So we did this. A new commit is created. Our subtraction code is here. So as of now, we can see addition as well as subtraction. Okay. So now once we are here, our professor on this day comes back and say, hey, I want division today itself. I don't want all of this. Just give me division. Remaining things you can give by the end of the week. Now you're in a really bad place, right? You have to get rid of addition and subtraction and add division on top. So basically you have to like remove all of your code that you've already written. So to make sure that we don't reach this situation, we can make use of branching over here. So whenever you're making some change, you create a branch to do that. Okay. So now, yeah, let's try to see how to solve this problem, okay? We'll revisit the same scenario. I'll need to reopen this. Just a second. Okay, yeah, we're here. So now let's say the same scenario comes in. A professor comes to us, says that, hey, you have to implement these 4 functions: addition, deletion, subtraction, and multiplication over 1 week. And you say, okay, yeah, that is doable. But instead of directly starting our work from this branch, we first create a branch for us. Okay. So we create a branch for us. Oh yeah, sorry. So the command to do that is called as git branch. what it does is it creates a new branch for you. So we'll create a branch called as project. Okay. So we created a branch called project, but this doesn't really take you to a branch. Your head is still pointing to master. See, your head is still pointing to the default branch created by Git. So let's ask our head to point to project. To do that, the command is still same as checkout. Remember, checkout is a command that you'll be using a lot. It can be used to go to some commit or even some branch. So here we say git checkout project. As soon as I do that, now you can see your head is pointing to project instead of master. And now we can start working on our code, right? So first day, we go ahead and implement addition. And now I'm saving my addition code. So yeah, my addition code is saved. And I'm on my branch called project. And my head is also pointing to that one. Now the next day comes in, I implement subtraction. Once that is done, I'll save that as well. Okay, yeah, good enough. Now in my code, I have addition as well as subtraction. So now I get the same problem. My professor is saying that, hey, don't give me everything, only give me division and today itself. So now what I can do is, like, now I'm saved because I still have my master branch over here. I can go back to my master branch using the same command, Git Checkout Master. This will take my head to my master branch. Now, if I look at my code, I will not see addition and subtraction because all of that change was not present till here. Whenever you want to understand what all changes you see all the changes at wherever you are present, all the way up to the root branch or the root commit. So now what I do is I implement division. And once that is done, I save all of those changes and do this. This looks a bit bad. Okay, anyways, so now see what happened here. This is like the exactly what happens when you create a branch. You have now this complex structure coming, but it is very easy to understand this. As soon as I did division, a new branch emerged from here, which had nothing but the division code. This is still the master branch and still the head. So see, here I did one mistake, which is I did not create a new branch for this. I made changes in my master branch only. Right. So the correct way to do that would have been to create a new branch, go to that branch, create the code for division, and commit that. In that way, my master would have remained here, and I would have received the correct branch over here. Okay. So now when my professor asks for the change, I can simply give them this branch, and they'll only see the division change. And later on, once I've given them that, I'll go back to my project using Git Checkout project. I implement my rest of things. For example, next day I implemented multiplication. So once implemented multiplication, I'll save those changes using Git Commit -m multiplication. And yeah, I'm here. So once I have all of this, I can submit my code to professor. Here, one thing that comes into picture is, hey, where is division? Will I have to implement division again? Can I not make use of this? So that is something that is a bit complicated, and that is something that we'll learn in our next session. But for now, what I would like, yeah.
Someone is asking, can you please just repeat the basic difference between master branches and other branches, or they are same list? Can you just repeat this part?
Yeah, sure, definitely. So master branch actually has no difference from other branches. It is still a branch. The only difference is you don't have to create a master branch. When you start a Git project, the first commit that you create is always on the master branch. So generally, what anyone advises you is, whenever you're making any change, you create your branch first, you go to that branch and start making your changes. So your master branch should always be present on your local system, basically your first commit or your correct commit, right? So this is something that we'll learn later on when we'll see what happens when we do merge and all. So, but for now, yeah, that is the difference. It is still a branch, but the only special thing is it is given by Git to you by default when you start a Git project. Okay, so now what I would like to do is, whatever we just saw right now, we should actually see this in action by actually going to create a project. Okay, So we'll go back to our project. Here, wherever we were in our project, we'll create our code by doing a vim input.cpp. So this is like my C++ file. I'm like not writing all of the code here. I'm just implementing some of the things that I have. For example, I'll implement int add. And here I'll say return x plus y. Here, so first day I implemented addition. I check what my status is. Uh, oh, that is wrong. Just a second. Okay, let me do one thing. Let me clean this up. So yeah, let me again do that. Vim a.cpp and then int add int x int y return x plus y. So we're doing the same thing as before. We have our code and we're trying to make some changes to it. Okay, so first day we added addition. So Git is asking me to add this file to move this to the staging area. So I'll do that. I added this file and now I'm trying to commit this. So I'll say implemented addition. Okay, so now I have code where I implemented addition. But I think, yeah, I made the same mistake as before where I did not create a branch, right? So just a second. Okay, I should have created a branch here. Okay. So first thing that I'll do is first I'll create a branch. For example, Git Branch project. So what happened here? Oh, it is doing this because there is no commit as of now. Okay, so we'll need to create first commit as of now. So let me do that. Okay, so now let's try to create a branch called project. So it now created a branch for me called project, but I'm still not on that branch. So you can see it is telling me that, hey, you are on a branch called main. So that is something that I can also see when I do a git status. So I'll go to that branch by doing the command git checkout project. So now if I do a git status, it is telling me that, hey, you are on a branch called project. So now let me do the same thing, a.cpp, and implement the function int add int x int y return x plus y. Okay, so yep. Now if I do git status, it tells me that, hey, you have a file called a.cpp, which is not yet added. So I add a.cpp, and then I do a git commit implemented addition. Okay, so this is done. Now let's implement subtraction. So I'll again open the file and int subtract int x int y And here I do return x minus 5. So I ask it what is happening here. It says, hey, you have modified a file. I ask it that, hey, can you show me what are the differences? It will tell me that, hey, you added these 4 lines where you had the subtraction function implemented. So yeah, this looks good to me. Let's go ahead and commit this. a.cpp git commit -m implemented section. So yeah, that's done. So now let's take a look at our log. So our log is saying that, hey, you can ignore this first commit. Like first commit is always leader by git to create any branches or anything. So that we did over here. So after that, we created a commit in which we implemented addition, and then we created a commit in which we implemented subtraction. So now our professor comes and say that, hey, you also need to implement division, by the way, and that you need to give by today. I don't want addition, subtraction, and multiplication as of now. So now what I can do is I need to implement that, right? So I can go to my master branch. You remember that master branch was like present at very beginning. That is also when you do git log, it tells me that hey, your main branch is present here. By the way, master has been renamed by main. So that is something which changed recently. So it is telling me that, hey, you're currently on project branch. So your head is pointing to project, which is on this commit. But your main is still like the first commit with no addition or subtraction whatsoever. So let me go to main. I'll do a git checkout, which is a command that we use always to go to any branch, and main. So once I'm here, let me check what I have. See, there is nothing wrong here, and I don't have a.cpp. So I again create a.cpp, and here I implement. Yeah, before that, sorry, I also should not do anything on the main. I should create a branch. So since I want to implement division, I'll create a branch called division. Okay. So to do that, command is called git branch division. But see, I'm still on the main branch. I still need to move out to division branch. So for that, I'll do git checkout division, and it will switch me to branch called division. So yep, let me create a.cpp and add that function here. Int divide int x int y, and then return x by y. So asking it what is the status, it is telling me that, hey, you have a file called a.cpp which is untracked. So why don't we add that? So when this is done, we'll add a commit message saying implemented division. Now if I check my git log, you'll see something different. It is telling me that, hey, now you no longer see those changes which we had earlier. Now we are only seeing that our head is on a branch called division, and we are only seeing the implementation of division. Okay, and then yeah, our first commit over here. So if I check what I have a file called a.cpp which has divide function in it. So I can go ahead, show this to my professor, they'll be happy. And then I can go back to my previous branch and start working on my work. So how to do that? I go to my main branch called project. If now I do a cat a.cpp, I see addition and subtraction, but not division, because division are actually present on a separate branch and are not affecting my work. Now I can go ahead, implement multiplication over here. And later on, once we are good, I'll go ahead and basically get the division changes over here as well. But that is a topic that we'll cover in our later session, which would happen tomorrow. Which actually I'm not sure if that will happen tomorrow or not. But yeah, hopefully soon enough. So yeah, I think that's all that we had, right? Shigar,
Yeah.
did I miss something?
No, it's perfectly fine. So yeah, just a couple of things I wanted to add. So yeah, and I now remove the shared screen. So one is like, guys, it's okay if you didn't understand anything, or if you understood only 40%, 50%, or 60%, that's perfectly fine, because again we call it as development because you can only learn by developing. So this is, so again we will be showing you an assignment, so please, and that's why we just kept it this session for only basic commands, because there are beginners who don't know, who might be not even use Git once in their lifetime. So first do that and try to cover it. It's a very small one, just you just have to repeat what we did today. And it's good if you keep on experimenting or something, because that's how you can only learn. So, and second thing is yeah, so second thing is just please, yeah, again do the assignment before coming tomorrow, and we'll be showing you the assignment. I'll add the assignment link in the description as well. And yeah, I think, and that's why we repeated the branch file apart, and branch is really important concept, so that's why we first showed you by a graph, and then we did the same thing again in the project. So yeah, I think we can just let me just share. Prashant, can you just share the assignment in the chat if you have the links on hands on?
Yep, I have that. I'll do that.
Guys, if, again, like if you have any other doubts, and you have I've got some of the doubts, so we will cover like rebase commands and git stash. These all commands we'll cover tomorrow. I'll soon set the link for tomorrow's session. Most probably it will be at 6 p.m. only. So, but again, please, at least those who are beginners, please complete the first today's assignment. Okay, I think, okay, wait, can't I copy? Okay, so anyway, okay, just a minute, give me 1 minute. I'll also share my screen. So this is the command, if you can copy, and I also can we link a GitHub profile on a computer? Yeah. So yeah, one more thing. Today we haven't even discussed about anything about remote, because it might be like so don't think about GitHub or something. GitHub is just a platform, you can say. So we are not even, we haven't even used it. So if you don't have a GitHub account, you can still perform the today's assignment, and this remote part like this GitHub and all these things we will cover tomorrow. So just for 2 minutes, I'll just share my screen so that I can just show you the assignment. Share screen, just a second. I hope my screen is visible. So it's a very small assignment. You just need to, and also we did not cover how to install Git, because it would have taken more time. It's very simple, and you can follow the many videos, or you can just simply use this link to install the Git first, who have not used Git. And then it's very simple assignment. Like you just need to create a folder, and please take a hands on the basic commands. And if you don't understand anything, it's fine. You can watch other videos, but and you can Google or something. But again, the main motive is so that you can understand. So please do the assignment, and if you have any doubts, you can again ping us on LinkedIn or wherever you want. So I think, yeah, today's session is complete. I'll add the assignment link and that website link in the our description. So I think, yeah. So I think, yeah, good. I think, yeah, it's happy weekend. Session is almost completed. So yeah, it was good interacting with you guys. Okay. Keep. Bye.
Yeah. Thanks a lot, everyone. Take care. Bye.